Okay, this is the final lecture we have, and it's just a summary, and the most important thing is probably down at the bottom here. So just some examples of functions that we spoke about in this mini chapter. Constant function of the form, no matter what real number you give it, it spits out the same thing. A line function is of the form fx equal to mx plus c. The slope of the line is m, and where it cuts the y-axis in the graph is c. Quadratic is of the form ax squared plus bx plus c, and a polynomial of degree n is of this form. So this is a polynomial of degree 2, and this is a polynomial of degree 1. Exponential function, you just really need to know that it grows very, very fast. An exponential function is of the form e to the ax, and we might just note that a to the x is equal to e to the log a times x. So anything that's to the power of x is an exponential function. The natural log is the inverse of this. Okay, absolute value function is given like this. The floor is given like this. This is just a fancy word for round down. This is a fancy word for round up. And then this is what we have here. So here you've got your constant functions which don't grow. Here you have your log functions which grow slowly. Here you have your polynomials which grow faster than logs. And here you have your exponentials that grow faster than polynomials. If the power is higher, the polynomial grows faster. And in the exponential, if the positive multiple of x is bigger, then it'll go faster. So for example, e to the 3x will grow faster than e to even 2.5x. Okay, and in here, x to the 7 will grow much faster, for example, than x to the 5. You can probably do a similar story with the logs, but I don't think I'd worry about that. The constant, of course, doesn't grow. Now, in the other thing, you can go to 0, and it's negative exponentials that go to 0, and the bigger the number in the power, the faster it goes to 0. So e to the minus, say, 7x is much, much smaller than e to the minus 5x. So these are going to 0, so they're very, very small, and the bigger the number, the faster they go to 0. So that's everything there.